Good morning, everyone. It is 10 o'clock on September 27th, so it's time for energy management systems. This is day one. You are at the lighting design lab. I hope you mean to be here. And today we have Michele Sagehorn from DNR Learn along with Diane Rasmussen presenting some really excellent information for, I think, all of the people involved with the Lighting Design Lab. And just as a reminder, if you haven't taken a webinar with Lighting Design Lab, we're using GoToWebinar, and I have a couple of screenshots. To ask a question to our presenters, it may look like that top one where you ask a question in the chat, or it may look like a question mark in a bubble. I haven't been on your end in the web version. I think that's what the web version is. Anyway, submit questions at any point and they'll get them answered because you're going to be on mute the whole time. Right when I opened this up, the webinar started being recorded, and we'll put that recording on the Lighting Design Lab's website within about a week or so of this class. And there's a survey at the end, so please take that. And before we get started, just want to make you aware that this is a two-part class. So if you're not registered for Thursday, make sure you do that or you won't be able to get in. And then starting October 11th, we're going to have another DNR Learn course, a heat pump deep dive. You may have taken our heat pump water heating deep dive, but this is heat pumps in general. And then a class that we haven't offered yet, electrification of the built environment, another 2-day class. When you get these slides, you can click those links. I can't click them right now. And with that, I will hand over to Michele and Diane.
Okay, welcome. We are going to be sharing the slide deck with you, and we'll also be sharing a link to our polling software, which is called Slido. So watch for the links in the chat, and if you have any questions, let us know. Thank you.
All right. Good morning, everyone. So first of all, let me just make sure I'm sharing my screen. Are you guys able to see the front page here that says Energy Management System?
Yep, you're good to go.
Okay, great. All right. All right. So yeah, so I'm Michele Sagehorn. Welcome, everybody. I'm glad you're all here today. To maybe start off, I can share a little bit more about myself. So I have been in the energy consulting industry for about 15 years now. About 5 years ago, I started a company with a couple colleagues called Redcar Analytics, which we also do energy consulting. But my primary role has been as a commissioning agent. And if you're familiar with that, basically I'm involved with a project, usually from the beginning, the design phase, all the way to the end of construction and into the operations phase. And with that, I get the opportunity to work with a lot of different designs, a lot of different building types, from offices to complex labs. And then I also get to see a lot of HVAC control systems, as well as if a building has an energy management system as well. So I definitely get a lot of opportunities to observe these systems in the field and see kind of what's working, what's not working, and I hope to bring some of those observations to this presentation today. So let's get going here. And as you guys know, this is a two-part class. Our agenda for today is kind of to define what is an EMS, and also kind of what is the business case for an EMS, like why would we need to buy one? And then we'll also talk about, what is a building management, a BMS versus an EMS, and why is it important to know the difference between the two? And then on day two, we'll do a little bit of a deeper dive into the EMS, kind of what are the things it does, well, how does it look and feel, and then of course, what maybe are the qualities that make it an effective EMS. And then my favorite, we'll get into some case studies. So the reality is that buildings are getting more and more complex, and it becomes a real challenge to keep persistent energy savings over time. Energy management systems are kind of a tool that's offered up as a solution to that problem. And so I think the question is it working or is it effective? Well, that's one of the things I hope to answer again in this presentation. So some of the key questions are, what are the value of an EMS, and how do I successfully implement and use an EMS? So if you actually buy and purchase one and install one in your building, it doesn't mean you're going to be successful. And we'll definitely talk a little bit more about that. All right, so today we're going to be using Slido, and it's going to help hopefully get us a little bit of interaction, get everybody kind of moving and grooving, and so it's not just me talking and presenting slides. So we're going to start off with a survey. If you guys could go ahead and go to it, there's two ways to go to it. You can go to slido.com and enter that event code EMS1, or you can use the QR code on the left-hand side on one of your electronic devices. But yeah, if you guys could go ahead and do that now. There should be a survey, and there's going to be like 3 questions there. So it'd be really great if you guys could participate. The first one should be pretty simple, just kind of how you're doing. It's okay if you're still waking up, but obviously we're hoping to have some of these interactions through Slido to kind of, again, get everybody engaged in the presentation. And as mentioned, feel free to pop any questions in the chat at any time. And then a couple, the 2 other questions are, what is an EMS? And also, if there's something specifically you're interested in learning today. And I think if you guys kind of provide any feedback on those 2, it's really helpful for me to kind of understand who's in the audience and also maybe what you want to know, so we can make sure we answer those questions today. So give everybody a few minutes to kind of get that up and hopefully give a little feedback. All right, looks like we got somebody on there. We are moving. All right, and I'm going to kind of flip between these questions. What is an EMS? A controller for an energy application. All right, energy management system, yep. All right. Are we interested in learning best practices to maximize energy efficiency? The best way to tie in lighting to a BMS. Oh, that's a good one. How to best aggregate data from multiple properties, best practices and risks. Okay, great comments. Okay, give it another second here, see if anybody else wants to chime in. Okay, an overview. I think we can handle that. All right, let me go ahead and just kind of move right into it. So what is an energy management system? An EMS is a software platform used to monitor, control, and optimize energy use. So if you listen to that definition, I think it's pretty straightforward, kind of easy to understand. And, with the visual on the right, I think we kind of have an idea in our heads what that looks like. But I'll tell you that honestly, when you're out in the field or when you're, in a building, it's actually not that easy to describe or distinguish. In fact, there's a lot of confusion that persists within the building industry on what constitutes as an EMS and how to use it and when it's useful. And maybe part of the problem is that not all EMSs are created equal. There's a lot of different varieties out there. Another problem is there is a ton of acronyms used within our industry, and often they're used incorrectly or they're interchanged. For example, an EMS, energy management system, there's also like EIMS, which is energy information management system. There's EMCS, energy management control system, and there's lots more, including when we get on the HVAC side, we have BAS, building automation system, and BMS, building management system, which actually is the same thing. So it can get quite confusing really quickly. But I will say that an EMS is a tool that helps us achieve energy efficiency in buildings, and it helps us track, obviously, our energy use. One of the most important things to start with an EMS system is that we need to measure information and data, right? So there's that saying that if you don't measure it, how do you improve it and how do you manage it? So that's really the first step, is being able to measure things, and then hopefully being able to get that information in a really kind of easy way that helps us make decisions and create things that are actionable. Because at the end of the day, that really is what makes an effective EMS, is making data actionable. All right, so let's maybe talk a little bit about the origin or timeline of energy management systems. So if we start in the 1970s, it was kind of known from the 70s to 80s as kind of an energy conservation period or focus. And it was really all about saving. And if you can recall, there was kind of a significant event that happened back then. We had gas and oil prices quadruple, maybe not all that different from what we've seen lately, but ultimately that really made people kind of pay attention to energy. And so it was all about saving energy. Maybe you can remember, like a lot of times in buildings, right next to the light switch, there used to be a little sign that would say, help conserve energy, switch the light off when you leave. And so it was really all about that, because in the 70s, there really wasn't the role of an energy manager, or they were just starting to evolve. And so they didn't really exist. And as far as energy management systems, I would say back then it was pretty manual. So it was probably looking at your utility bill, maybe entering it into a spreadsheet. But then as we moved into the 1980s, that term from energy conservation actually changed to energy management. And we started to see energy management roles, like companies, appointing somebody to that role and really putting more focus on it. Another significant event that happened in the 80s was obviously the introduction of the personal computer. So that also helped, because now we started to get actual tools that can analyze and do analytics on our data. And so that's probably where some of the first automated energy management systems started. But as we moved into the 1990s, things shifted again. We started to see energy prices decline and corporations start to downsize. So when that happened, it became really challenging to kind of justify energy efficiency projects. You know, they didn't pencil out. There wasn't that simple payback period. But then as we moved into 2000 and up into where we're at today, there's obviously been a refocus on energy. It might be termed differently. We might hear different terms like carbon reduction, clean energy, and climate change focus. You know, the climate change agenda became a major focus for a lot of individuals and companies, and we started to see people making, bold statements and clear commitments to reducing their energy consumptions. And of course, computers became, they evolved and they got faster, cheaper. It was a lot easier to store a lot of data, analyze a lot of data. So definitely started to see a lot more tools in the last couple of years. So speaking of tools, I wanted to start off with a tool that is used on energy management systems. But as I mentioned, it probably started with a utility bill. But as we kind of move into an actual tool, one of them is benchmarking. And this is probably one of the first tools. So benchmarking is really kind of just collecting your energy consumption over a 12-month rolling period. And so as a company, if I was going to ask you, probably one of the questions you would ask is, how am I doing? Am I doing good or bad, or where do I fall? And so by benchmarking and looking at, 1 year versus the previous year and so on, we can start to see, am I decreasing or increasing my energy use? So that's one way to indicate whether or not you're doing good or bad. But then we can take that a step further, and we can take that energy usage over that 12-month period and divide it by square footage of the building, and we can start to compare like buildings to each other. Now, we couldn't compare an office building to, let's say, a lab building. They're different. I mean, a lab building is probably 24/7. It has a lot more energy intensity equipment, as well as it requires a lot more ventilation air. So again, not a fair comparison, but we can start to compare an office to another office across the United States. So now we know if we're above or below the average of, a like building, and that gives us a little bit of indicator if we're doing good or bad, or where we're at, and if there's opportunities for energy efficiencies savings. Benchmarking, don't get me wrong, it's a great tool. It's still used today and is part of probably most energy management systems as a generic or a tool that's always there. But what I would say is, let's say we realize we're not doing good. What do we do then? And how do we find out what to do or what to improve or fix? that's where I would say that benchmarking cannot be the only tool in our tool belt. We need more tools to be able to kind of figure out what's going on and kind of focus in on the energy savings opportunities that might exist. So let's go ahead and look at another tool. Another tool as we kind of evolved here is with computers, because we can now, computers and programming obviously make data accessible. They also make it very visual and hopefully, again, usable. And so we're going to talk about all three of those things and how important they are to, again, making an effective energy management system. But another tool that you'll see is what's called a load profile. So a load profile is, again, your energy use over a 24-hour period throughout your building. And what you typically see, let's just say again, an office, is kind of like a bell curve. You know, during the evening hours, there shouldn't be anybody in the office. We shouldn't be using energy, so it should be a lot lower. And then, of course, during the day, as either temperatures or people increase, we start to see the load increase, and at some point we peak. That particular load profile can be very useful because it's really telling us when our building's using energy, and it's also telling us maybe the peak amount of energy we use in a given day. And although that's important, we can also take it a step further, and we can start to overlay, you know, Monday, Tuesday, Wednesday, multiple days on top of each other. And what you're going to start to see is, you know, patterns. You know, hopefully you can recognize when there's a spike or an anomaly or something unique that maybe doesn't look right, and then that can help us kind of dive in a bit deeper. But in order to start using some of these more advanced tools, what we need is real-time data. And so a lot of clients are installing meters and sub-meters beyond just your utility grade meter, so that we can have access to real-time data immediately. You know, we're not waiting for no utility bill. We're not waiting. We can see what's happening in the moment. It also provides us the opportunity to really increase the frequency of the data. You know, we maybe want to see it more than daily. We want to see it hourly or by every minute. Some people go even further than every minute. But ultimately, that increase in frequency really helps us to see what's happening right now and how we're using energy. And at the end of the day, it allows users to make decisions more frequently about their energy use. You know, as we see buildings start to have kind of on-site generations and storage facilities, or want the ability to do load shedding, we need to know how our building's performing in the moment. And so that is one of the nice things about, as we've evolved and can use computers, they are automatically collecting that data on the, you know, whatever interval we need them to do, and it's automatically there for us. All right, so let's go ahead and, you know, right here, pause here. I'd like to show you a couple actual real life EMS or energy management systems. And what I'm showing here are three unique clients. We have the state of California. We have a campus, which happens to be a university at UC Davis. And then we have just a building. And as you look at these, you might notice a couple things. First of all, what I notice is that each one of those they look different, you know, they're unique. And that's pretty typical for an energy management system. They tend to be customized for the client and kind of what's important for them, what's important for them to measure. Another thing you might notice is that there's a lot of visualization. So there's charts, graphs, you know, multiple data points on a graph, maybe some widgets. But again, the way that we display data is also important and helps us kind of see those patterns, those anomalies, and hopefully either issues or energy opportunities a lot quicker. One other thing to mention is the word dashboard. Dashboard is one of those terms that often gets interchanged or used inappropriately as well. I would just say, just to kind of keep that in perspective, when I think of a dashboard, I think of it being mostly informational. You know, maybe there's like the state of California one. I feel like that particular EMS is giving information to the public of what's going on with the energy system in the state, you know, at any given moment in time. So it's more informational, which is still good, but at the end of the day, again, an effective energy management system is going to take that data, do something with it, and give us some useful information so we can act upon it. So what I wanted to do now is actually go to one of them. And one of my favorites here is this UC Davis. But also I would say, you know, the websites, the links to the websites are right here below. And you guys are definitely more than welcome to go take a look at them. I find them really interesting. But yeah, feel free on your own time to kind of browse through them. But I'm going to go ahead and go to this, this UC Davis. And so hopefully what you're seeing on the screen right now is that visualization again. And what you're looking at is their entire campus. And so all the little dots are the buildings on campus, and then the larger dot, or the circles around them that are kind of transparent, are their energy intensity. And obviously the larger the circle, the more energy the building uses, and vice versa. So as an energy manager, if I looked at this, I'm able to see my entire campus and really see which buildings are using the most energy and which are not. I think that's a really easy way to see it. And like I said, it's one of my favorites here. So let's go ahead and look at a building, this Young Hall here. So when you click on it, it gives you some information. The first thing you'll notice is it tells you that it's a lab. And so there's a little bit of verbiage there kind of explaining why labs use more energy, and they're typically going to be a little bit higher than maybe your library or student center or other buildings on campus. What it also provides you is what's called an EUI Energy Use Index. That's kind of our benchmarking, our 12 months worth of data divided by our square footage. So that's what an EUI is. So it's telling us 555. Now, if it just gave us that number, again, would you know if that's good or bad? But below it, talking about that database that is out there, we're able to now say what the average lab is across the United States. It's 210 kBTUs per square foot. So now you know that this particular building is twice as much as the average. Again, if I was an energy manager, this might be a building I might want to look at or focus on. Hopefully there's some energy savings opportunities there. Where if we go look at another building like this Shields Library, we see another number again, the 62. That's the EUI for this building. But when you look at the average in the database for a building of this type, you'll see it's 124. So it's well below the average. This might be a building where it's, there's not a lot there to do. Maybe there is, but again, it might not be top of your list. If you have a budget and timeline, you might go after the bigger energy users. All right, let's go back to this Young Hall, and I wanted to show just a few more things here. When you click on it, you're able to get a little bit more information, but then you're also able to go to view energy data. This takes a minute to load here. Let's see if we can get it up. All right, so now you're looking at the data for this building over the past 24 hours, and this building has a chilled water system, a steam system, and electric system. Let's go ahead and just look at the chilled water for a minute. So if you look at this data, I guess my question would be, is this good or bad? Probably we don't know. But what I wanted to point out about this website that I haven't seen on many energy management systems is if you scroll down a little bit, it'll give you a description of the chilled water system and kind of how they're using it. But they also show you how to look at the data and what is good versus bad. So it's giving you a clue on how to read that data. Basically what you look at on the normal use is that, in the evenings, again, when the weather and the temperature goes down, we expect there to be less cooling demand, and therefore we expect the energy use on the cooling system to go down. Where the chart on the right, if we see a pattern more like this over a 24-hour period and pretty much kind of just always a lot of energy, there's probably a problem, and that needs further investigation. So again, I think this is really important to point out, is that data is great, but we need to know how to use it, and we need to know whether, again, we need to do something about it. One last thing, on this site, there's lots of tabs and lots of places to go and look. So like I said, feel free to kind of jump in there. But what I wanted to show you is that they actually are keeping track of their energy savings across the campus. And let's see if this pulls up here. And they do it by building. Okay, here we go. And so they're kind of broken it up by type of utility, electric, steam, or chilled water. And by each building, they're doing energy efficiency projects on. They're keeping track. Green obviously being positive, and red maybe not so positive. But ultimately, what the point I wanted to point out here is that I mentioned in the beginning, just because you have an energy management system, it doesn't mean you'll be successful. We might get an energy management system that tells us what the problem is. It might even give us suggestions of how to fix it. but still, usually somebody has to go do something. And so therefore, there has to be people involved, there has to be a process, and they have established a process here for their campus and how they deal with energy efficiency projects. And that's really the point I wanted to make. We'll talk about this again a little bit later, but just kind of wanted to point that out while we were here on the website. I'll go back to the presentation. All right, let's keep it moving. All right, so a couple more examples. So an energy management system, as we just saw, like with UC Davis, it usually has a lot of different pages, a lot of different views and charts, and that kind of depends on, again, who's the user and what do they need as far as data. But to give you a couple more examples, let's go ahead and look at these. Let's look at the one at the bottom right, the energy use one. I kind of call this one a standard. Again, this is something that I feel every energy management system should have. So it's really just looking again at your energy use. This particular chart happens to break it out by your end use. So, your HVAC, your plug loads, your lighting, domestic hot water and process loads. So it's kind of broken it down by end use. And we're able to look at the data, for a couple months there. And what I wanted to point out here is that when you look at this, there's something that kind of pops out, at least for me. I mean, to me, it's like, okay, it's very clear that the HVAC is the largest energy user in this building. And that's really that's the intention here behind a visualization, is to be able to pick that out really easy and quickly. Again, if I was going to do an energy efficiency project, that might be where I would start. So that's something that's important, but it is a lot like when you get on if you log into your utility bill for your own home, is usually you can see, if you have a smart meter, how you did from, you can see the whole week, or you can compare 1 month, like June, to the month previous year of June. And that kind of information can be extremely helpful and just good to have. And that's kind of why I call it kind of a basic tool to be part of an energy management system. So we look at another one. How about the HVAC one on the upper left-hand corner? This is called a heat map. And a heat map is generally 3 colors. It's usually green, red, and a color in between, like orange or yellow. And obviously red usually means bad and green means good. In this case, what we're looking at is an HVAC system and the energy use. And again, it's a typical office building. So you would expect the energy to be kind of off or very low in the evenings, which is what we're seeing here in these green parts. And the red is kind of your typical office hours from 7 a.m. to 7 p.m., let's say. And you can see that everything kind of looks normal. And then when you see the one at the very bottom, you can see it goes red all the way across, kind of indicating that your HVAC stayed on all night long. Obviously, again, it's really easy to see that. It's easy to see what days and what went wrong and why. So that's what's nice about a heat map, is you're able to see a lot of data on one chart, because this might be about 2 weeks worth of data over a 24-hour period. So again, it's a really nice way to visualize a lot of different pieces of data on one chart. And then one more, let's look at the plug load one in the bottom there, left-hand corner. And this is our load profile, again, like what we were talking about earlier. And if you had just one load profile there, it'll tell you something. Again, it tells you how much energy you use and what a peak is. And obviously you're, again, lower in the evenings. But again, if you overlay multiple days on top of each other, now something kind of pops out, right? So they actually did an energy efficiency measure. They noted that computers were being used at nighttime. So they shut them off, and obviously you can see it did save energy. So they were able to confirm their energy efficiency measure, and you're able to probably quantify how much energy you actually save by implementing that measure. All right, so again, these are just a few of maybe some of the visualizations or pages you might see on an energy management system. Okay, and another example is for an EMS, actually, let me say, this is typical of a BMS. Like, as a commissioning agent, what we're looking at here is a chilled water system, and we have some data that's being trended over time. The top line is outside air temperature, and the bottom line is our chilled water gallons per minute, so how much we're flowing of our chilled water. And if I was a commissioning agent and I wanted to say, hey, what is this system performing properly? I would look at this data and I would say, yeah, it looks good to me. Because what we're seeing is as the outside air temperature drops, again, as it gets colder, we shouldn't need as much cooling, and therefore we should be able to turn down our GPM and not deliver as many gallons per minute to our load. And so that's what we would expect to see. But if we're able to add one more piece of data, and we're able to add our energy data or power data, we have our chilled water pump amperage. And when you see this, you see it's a straight line. By adding this piece of data, now we revealed a problem because ultimately it shouldn't be a straight line. As a GPM goes down, our pump speed should go down, and therefore the power or the energy use on the pump should also kind of follow a similar pattern as those two lines as well, which is not what we're seeing. So by bringing in this energy data, really it's, in my mind, we're seeing the whole picture. Before we were not seeing the whole picture. And that's another advantage of an energy management system, is we're able to see a lot of different pieces of information together in one location. Where a BMS, you might only get the outside air and the GPM. Now that being said, there's a lot of BMSs that are starting to bring in energy data, but I would also say that they typically don't always display it in the right way to see something like this. So it's about the right data and also displaying it in a way that you can see the issue. Okay, so what is going on in the marketplace, or what's happening out there? What innovations are going on around energy management systems? Well, I wanted to talk about a couple of them. One of the buzzwords out there that maybe you've heard about is analytics or analytics software. And I always get asked the question, is analytics software an energy management system? My answer to that is yes, as long as it's collecting energy data. And so let me describe a little bit of what it is by using an example. So on a typical building, we would probably have an air handling unit. One of the energy efficiency measures that is actually required by most building codes is to have an economizer. An economizer basically means we just bring in outside air when the temperature or the conditions outside are good or mild, and so that we don't have to heat or cool the air and ultimately save energy. So that's great. The reality is that most economizers don't work. I mean, they notoriously break. And so how do we know if it's operating properly? And again, if I was a commissioning agent, I would have to go look at a lot of trends on the BMS. I might need to look at outside air temp, return air temp, chilled water valve position, maybe damper position. So a lot of different points. It can take a lot of effort to get them all, again, on the same chart and to be able to kind of analyze that. Where what an analytics software does is it has all the smarts kind of already and a lot of the logic built in. So it will read all those data points that I just kind of pointed out, and it'll do the analysis and logic for you. And what it'll spit out instead is say, yesterday there was 3 hours out of the day where you should have been in economizer mode and you should have been saving energy, and this is how much you would have saved had you been in economizer mode. And that's what an analytic software does, is that it takes some of those typical energy efficiency measures, and it kind of does that analysis for you behind the scenes and then spits out useful information. Another thing that's kind of associated with that you may have heard of is kind of predictive algorithms or AI, computer learning. I would say the industry is definitely trying to go that way. I have not actually seen that implemented on a real live building yet. But what they're trying to do with that is to be kind of proactive instead of reactive. So even if we have our own sub-meters and we are seeing stuff every minute or maybe even every second, we are seeing what's happening in the moment. What they're trying to do here is kind of go out and be proactive before something actually even happens. So an example of that would be, I'm going to go out and look at the weather data, and let's say Thursday it's going to be really hot out. So what the AI or computer learning would do is then say, I'm going to go change my set points, off my air handler or wherever, maybe in the zones, and I'm going to go change it. And then I see that the weather on Friday maybe dramatically goes back to being cooler outside, or the high is 20 degrees less than it was the previous day. So then it'll go change the set points again proactively so that we make sure we do save energy. should help with comfort as well, but ultimately, again, trying to be proactive instead of responsive. So that's kind of where they're trying to go, or where I would say one of the things that they're working on. Another thing that seems to be important to clients is being able to track things besides energy or HVAC. I do see a lot of clients really interested in kind of attendance / productivity, because that's a big cost for companies, right? So they may want to know how often the conference room is being used, or maybe they even just keep track of the badge, you know, how many people are actually in the building day to day, and they look at that from a comfort complaints and kind of look at the data in different ways. Another thing that's really important these days is kind of indoor air quality with like fires and obviously with COVID. So there's a lot of clients that are interested in monitoring that and kind of keeping an eye on that. And one of the ways to get some of that information from different types of systems, like I mentioned like conference rooms or something like that, is there's a lot of devices out there called IoT, the Internet of Things. So they easily can kind of integrate into an existing system, you know, through the internet. So we might be able to bring in different pieces of data that are not HVAC or whatever, but use them for our analysis and maybe have some correlation or relationship between them. One other thing that's popular, and I wouldn't say it's necessarily new, but there's definitely a desire to have all of your information in one location. And even now, when I'm doing commissioning on a new construction project, it's pretty typical to have a lighting system and it have its own front end, and then to have like your HVAC, your BMS over here, it's got its front end, and then you might have another one for your meters, your electrical meters or sub meters, and maybe even another one if you have a PV system. So you can imagine having to log into 4 different systems, and you might want to see all that data together. For example, a perfect example is somebody who's trying to go for net zero in their building. You need to know how much your building is consuming, and you need to know how much it's producing. So you need your solar data, and you need your, you know, meter data, and you need it in the same location on the same graph to see if you're achieving, you know, again, if you're on track for net zero. So that's a good example of that. And there's definitely more of a desire for that. You know, an energy management system is perfect. It can actually bring in all the data from all those things and make it into one location. So that's one way to go about it. Although we are seeing, I think somebody mentioned in the beginning they wanted to talk about kind of lighting integration, and we will definitely get to that. But we are seeing a lot of those things being integrated into a building management system as well. And you know, as we talk about, and we're going to get to that section of BMS versus EMS, I would tell you that the marketplace is constantly evolving. So, you know, what's true today may not be true in a month from now, but BMSs are trying to evolve, and we're starting to see BMS products on the market that are, and you know, including some energy management tools, visualizations, things that we're talking about here today. So there's definitely, we're seeing that marketplace change and kind of try to evolve into having a BMS and an EMS in one location as well. And then of course, maybe the last thing I'll say is we're seeing a lot of obviously need and want for having, you know, controlling features like demand control, demand limiting, and load shedding on systems as well. And yeah, that's kind of maybe a quick summary of what is kind of happening or what I'm seeing out there. And so we are going to kind of pause here for a minute. We're going to have you guys do another active poll on Slido and maybe see if, you know, you've changed your mind on kind of what the definition of an energy management system is, or if you have any additional thoughts on that, it'd be great to hear. So we'll give it a minute here and see what everybody has to say. All right, aggregates data from various systems, allows monitoring control. Yep. Great response there.
Michelle, I sent you a message in chat.
Uh-oh. All right, let's see. I don't think so. Are you seeing something different?
Yeah, I am. I took the slide from our area in Google, but it, like these last couple slides I didn't have.
Interesting.
So I'm kind of confused.
Okay, has this been sent to the Seattle?
Yeah, I sent it to the whole audience, so
Okay. All
I
right,
want to
maybe
get them the right one.
we should follow up with that. Okay. All right, let's see. We got dashboard for energy. Great. A platform that can incorporate data from a variety of systems, present it in a comprehensive way. I like that. A system to track and monitor energy use, trend, and determine hotspots to find out areas of concern. All great answers, guys. All right. Wait another second here. Looks like we might have one more person. Okay. Okay. Got a little joke there. Good. Nice to lighten the mood. Thank you. All right. Let me go ahead and move on. Okay, so we are going to move into our next section here, which is kind of the case study for an EMS. So why would we buy one? Why do we need one? And so let's start talking about that. And we're going to start off with maybe our first kind of interactive exercise here. This is a case study of obviously a real building, a real client. It's the JW Marriott. I'm sure you've heard of them, a hotel chain. Basically, what this is that it was one hotel and they decided to implement an energy management system. They had a lot of success, and then they obviously shared that with the larger company. You can see some of their success right there, the 7.8% energy reduction, carbon savings, and of course the dollar savings. So what we'd like you to do is we're going to put the link to this case study in the chat, and we're going to have you guys read it, give you about 10 minutes here, and then there'll be a little Slido poll afterwards. But ultimately, just kind of want to see what's your thoughts? Again, we're talking about kind of the business case for an energy management system. So, what are your takeaways from this particular case study? So, all right. So it looks like Diane's got it in there already. I'm going to go ahead and put myself on mute, maybe turn off my camera here, give you guys 10 minutes, and then I'll come back online. So let's say about 10:52. All right.
There's also a question in the questions area.
Okay.
It says, how common is it that all of those systems can communicate with the EMS platform?
Well, I'm definitely seeing a lot more of it. This is something that I've been seeing lately, is if you do, especially on new construction, if you do implement an energy management system, the best way to utilize it is to bring in a lot of those different sources. And like I said, what I probably see the most of is a lot of clients, definitely there's a lot of clients out there trying to be high performance buildings or net zero, and just simply, again, seeing your production versus consumption. So there's definitely a need there. And like I said, I think you get the most out of your energy management system if you can bring in all the different sources of data. And if that's done in the construction phase, bringing it into the EMS can be kind of not too bad as far as from a labor perspective, because you're kind of, most new construction is going to have a building automation system anyways. And so you're doing a lot of that work anyways, and then you're just kind of collecting the data, making sure you're able to gather it from the different sources. I'm not going to say it's necessarily easy all the time. There's always some hiccups here or bugs to work out as far as communication between different manufacturers and devices and so on. But yeah, I would say it's getting a lot more common, for sure. All right. Is that all the questions right now, Diane? I think.
It looks like he responded with, but are the protocols compatible?
Okay. It's definitely getting better. Again, I've been doing commissioning here for 15 years, and it definitely was times where it was really painful, and that didn't seem to be the case. And we always seem to be missing something, a driver or not the right, like you said, language, backnet to LawnWorks or something like that. But now, even though there's still hiccups between systems, and lighting's a good one because lighting systems tend to be a bit more proprietary, I'm still seeing that it's being a lot easier to integrate the systems together, and that there are ways to make them communicate. We're starting to identify those better in the design phases so that we don't have those hiccups in the construction phase. So hopefully that answered that. But I would say most systems, there is a way to get them to all communicate. Some easier than others, but I haven't found too many cases where without a little bit of elbow grease, we weren't able to get the information that we were looking for. All right, gonna have you guys start kind of wrapping that up and get things moving here again. All right, I'm gonna go ahead and hopefully activate this poll. Oops, sorry. And basically the question is kind of what was your key takeaway from this case study? Let's see, we got 2 questions, sorry. And also what factors were essential for the success of the energy management system? So while you guys are kind of working on that, maybe I'll share some of my observations. I know that this particular section, we're talking about a business case for an energy management system. You know, why would you purchase one? But there was some things in that case study that really stood out to me that maybe are not directly related to a business case for it. But I still wanted to point them out. What I took away from them as far as kind of some of their keys to success was, one, I noticed that there was like commitment from the management group. They had created a team, and their team was multidiscipline, a multi-department. So we're definitely getting experts from different areas to all participate. They created a process, and then they also trained the staff. Again, you know, teaching them how to look at the data and how to analyze it and so on. And then one of the other things that I thought was great was that when they had the results, they were communicating that with employees. It's really important to also engage employees and kind of let them know what's going on and that they play a role in how much energy is used within a building. So those were a couple things that I noted in their case study. Like I said, that maybe aren't directly related to a business case for buying it, but it definitely was keys to their success. All right, we're getting some participants here. One takeaway was that they saved an oppressive amount of energy slash dollars, but it did require a bit of planning, staff, and coordination. So yeah, I think that kind of is aligned with what I was saying as well. It can get harder to save more energy as a building gets more efficient. That's a great comment, and it really is. And that's where I think another real advantage to an energy management system is it can get, with some of the logic and analytics that are offered out there, we can get in, do a lot deeper dive, and then go beyond just what they call the low-hanging fruit, right? Okay. Outside of the EMS, I'm impressed by the approach of involving employees at every level, from general manager to directors, even including hotel associates like kitchen staff. Yeah, I totally agree. So great comments there. Let's see. Go ahead and advance that. Data and documentation, absolutely needed. So totally agree. Buy-in from employees across the spectrum in investment in getting everyone on the same page. Absolutely. You definitely have to have that commitment. Probably not going to be that successful. Would have been good to see the financial story of it, materials cost, internal, external, incentive, savings, benefits, payback. I agree. There definitely was not too much detailed information there, so that would have been nice. I'll take a note of that. Maybe I can find a better case study for the future, because I agree that would have been nice to have. So thank you for your comments. Let me go ahead and move on here. So again, talking about the business case for one, you know, obviously another driver that could be a business case for an energy management system is our just climate change goals. This happens to be a chart for the state of California, but I am sure that the state of Washington or the city of Seattle also has some goals related around climate change. The graph on the left-hand side is showing California's greenhouse gases emissions. And what I would like to point out is that if you look at 2050, you'll see that we're trying to get 80% below the 1990 level. That's a pretty steep line, pretty aggressive goal. So the other thing is California is trying to, by 2050, to be all on renewable energy sources. And so we know we have some, you know, obstacles to overcome. We have reliability concerns with our state utility grid and so on. So there's definitely a lot of challenges out there. So how do we get there? Obviously, sometimes it's just straight up, you have to do it, right? Code driven. It's not just a goal, we actually have to do it. So in California, I'm not sure how Washington is, but California, that code is recycling every 3 years, and each cycle, it gets harder and harder, and there's probably more mandatory requirements focused around energy efficiency. So again, an energy management system helps us kind of achieve that. Also wanted to kind of point out the chart on the right. As you guys probably all know, buildings do play a big role in our energy consumption. On average, commercial buildings have been found to waste about 30% of their energy that they consume. So we definitely play a role in, you know, the solution or getting to our goal, and being able to kind of look at our energy use. Again, that chart is showing us by energy use there. And, you know, we can, again, easily see what's using the most energy, our space heating in this particular commercial building. But ultimately, again, we do play a role in being able to kind of help get there is key. And an energy management system can do that. As well as, you know, we have some programs that are maybe still not mandatory, but like, again, load shedding and things like that, having the ability to do those things, because we have to be creative also as far as our way to get to those really tough goals. On this particular chart, or excuse me, slide, you know, this is going to be more about maybe compliance requirements, but also maybe about sustainability choices. So that's another, again, business case for an EMS. The logos on the right are what I call certification programs. You may be familiar with some. Probably the most known one is the one in the middle, the U.S. Green Building Council. So they have, it's called LEED. And ultimately, a lot of times companies choose to do it because it's just, you know, good stewardship, you know, doing the right thing. But I'm finding that a lot of cities and ordinances are now starting to actually make them mandatory. So sometimes they're a choice, sometimes they're mandatory, but ultimately all of these types of certification programs focus on sustainability. And I'd say beyond just energy, but in general, there's also a big portion of it that is obviously focused on energy. Some of them actually require you to have advanced metering or sub-metering. Some of them require you to have an energy management system. So they're all a little bit different, but I would say sometimes there, you know, if you're going to do any of those things, you're going to probably have to install an energy management system. I do believe, and you know, someone can correct me if I'm wrong, but I saw a flyer from actually the Seattle Energy Code that said that new construction in Seattle requires an energy management system to be installed. And what I really liked about it was in the flyer, it described not only, you know, what an energy management system is, it gave those basic things of what they're expecting the energy management system to be able to do, like benchmarking or an energy load profile. It was very specific on some of the tools and some of the functions that this energy management system needed to have. And I thought that was really great because, again, kind of going back to the industry on what people think is an EMS or a BMS and what tools and which features it needs to have is a lot of times up for debate. So I thought it was a really nice little pamphlet put together. It's definitely something we're not quite doing here in California. So I kudos to you guys. But I think that's, yeah, actually a requirement for new construction there. You know, I think maybe the last thing is, of course, the obvious thing is that, you know, energy management systems do save energy and ultimately can save us money. There is a study out there. The most recent one I could find was from Better Buildings Institute. It's not Institute, Better Buildings. Let's see, what is it called? Let me see if I can find the reference. Well, they are a part of the DOE, and I can get this for anybody who's looking for it, but they also did this with Lawrence Berkeley National Lab. And basically, they were able to kind of get some real data from real buildings. And they found that a typical energy management system did have a payback of a year, on the high end being 2 years. But typically between 1 to 2 years was the payback for an energy management system. They gave kind of an average cost, median cost to install it of around 8 cents per square foot. And they said typically they are seeing energy savings each year between 3 and 9%. So that's where I was able to gather some real data from real buildings that have recently installed energy management systems. But at the end of the day, they typically, again, tend to be a lot cheaper than a building management system. They pay back well. And they what else was I going to say? I mean, basically, data collection and storage is also very cheap these days. So at the end of the day, I think they do make sense from a business case perspective. Okay, so we're going to go ahead and pause for questions, and then I think right after that we're going to take a 10-minute break. But let's see if anybody has any questions. Quickly. Okay, what I'll do is I'll leave this poll up during the 10-minute break. So if anybody wants to, you know, throw something in there at any point, go ahead. So if we take a 10-minute break, let's be back here at 11:12, please. And talk to you guys soon. All right, welcome back, everybody. We do have one question that I'll try to answer here. So how close are we to a universal protocol that will allow true plug and play of systems and devices? That's a good question. I would say, like, when I think of sometimes like some of the stuff in my house, on more on the personal level, not commercial, maybe residential, I've seen more growth and it'd be a lot quicker. And, you know, we're definitely getting there. On the commercial side, it feels like we're still a ways away, unfortunately. I feel like there hasn't been as much attention in this arena. And the HVAC controls. I mean, I do feel that's changing to an extent. There definitely is on the analytics and energy management side of things. I'm seeing progress. There are, you know, a lot of initiatives out there where it's not exactly answering your question, but there's protocols on how to name points and data, and we're going to talk about that a little bit in day 2, to kind of standardize across the industry, across a building or a campus, and that makes kind of analyzing data a lot easier and cleaner and so forth. So that's making it much more powerful. It's more like a database and we can do a lot more with it. So there is definitely progress being made, but I wish I could give you an exact date, but unfortunately not. Looks like we might have one more coming in, so I'll hold on here. Yeah, I know. Well, more technology, more problems. Yes, there's definitely growing pains, for sure. All right, let's go ahead and move into our next section and our final section for today, the BMS versus an EMS. And we're going to start off with another exercise, guys. So we have a couple articles to have you read. They're pretty short. So we're looking for you guys to read 2 out of the 3 articles. The one at the top, the one that's kind of got the therma there and it's called BMS, BAS, or EMS, which building system's right for my facility. We'd like you to read that one. And then the 2 at the bottom, we have an option 1 and option 2. So you can pick either, whichever you choose. And so again, I think Diane will put those links in the chat. While you're looking at these or reading through these articles, I would ask you to kind of pay attention to the reflection questions, you know, understanding why is it valuable to understand the difference between the 2 systems and where does it get muddied, you know, as far as the definition and things between a BMS and an EMS. And then again, we'll have a little bit of a Slido poll afterwards. And we're gonna, again, take about 10 minutes to do this exercise. So let's see. I don't have my chat. It looks like we got that in there. Diane, I'm sorry, I can't see the chat right at the moment.
I'm not seeing the links.
Yeah, I'm not seeing them either. Diane, are you there?
There they are. They just showed up.
Okay, perfect. Perfect. All right. All right, guys. Again, I'll give you about 10 minutes and then I'll come back in and kind of let everybody know to wrap it up. Go ahead and get started. Thank you. All right, guys, if we could start to wrap that up, if you're not already finished, and let me go ahead and activate our poll. Okay, so I think we got a couple questions here. Obviously, why is it valuable to understand the difference between a BMS and an EMS? And where are the waters muddy between those two systems? So I'm curious to see what you guys think. Definitely not really necessarily a right or wrong answer, but interested to see what you guys think. All right, well, I'll give it another minute here and maybe I can share, I'll start to share maybe some of my thoughts. I think, one of the things kind of going maybe to the second question, where these two systems get muddied is, I mean, there's a lot of things that they both do. They both can save energy. A BMS can save energy. I mean, as simple as the BMS controls the HVAC equipment. We can go to the BMS and actually turn something off. That ultimately saves energy. So, there's this thing about energy, but at the end of the day, both systems can do that. They also obviously collect and measure data, and they can analyze it. So there's definitely some things that they both do, and that's where it can get a bit tricky. And I see some stuff populating here, so I'm going to switch over to the poll. And going back to that first question of why it's valuable to understand the difference. BMS can take action automatically and EMS can assist in planning. Okay, definitely agree with that. BMS is definitely kind of more intentional on the control side and EMS can be a lot of proactive in planning. Yep. They do different things and depends on the site, which you might better take advantage of, or you might need both. Okay. One collects data with no automatic functions. The other does the controlling of equipment. That's true. Like I said, the BMS is definitely more of a control type system. They both have the ability to collect data automatically, though, I would say that. Let's see, one more here. Depending on the facility or building, it can be more cost effective to use one over the other. That's a great point. Some buildings don't need a building automation system. There is a saying that sometimes controls can be too complex and we don't actually save energy, and sometimes simpler is better. And for a facility like that, you still may want to know how you're doing and know how you're performing, but you maybe don't need all the bells and whistles of a building management system. So that's a great comment. All right, let's move on to the waters where they're muddied. Which system is to use when needing to choose only one system on an existing building? Buildings that use both systems, the manufacturer installing similar functionality on both systems. Again, yes, that goes to my point where BMSs are starting to evolve and add some of these EMS features, making it even more muddy. So that's a good point. Which system to use when only needing to choose only one system on an existing building? That's a good point. Existing buildings, if they don't have a building automation system, it may be best to kind of move forward with an energy management system. It may be the most cost effective. Again, it depends on what you're looking to do with it, but for sure. When BMS starts to include some functionality of EMS, what if the data doesn't agree? Which do you trust, assuming you have both systems? Another good comment there. This is something that I'm kind of running into in my job as a commissioning agent, because the new LEED version 4 that a lot of buildings are going for, that certification. I mentioned that there's a credit for monitoring-based commissioning, which requires an energy management system. So if a client chooses to do that, I include commissioning of both the BMS and the energy management system. because the energy management system doesn't always come with a building or a new construction, it's not an actual requirement by the code or by like that LEED thing, certification. So, but it's very important because like you said, you have to be able to trust the data. You have to know what the true source is, and ultimately, ideally, obviously, they should agree. So, you know, commissioning is obviously one way to do it. And I don't think sometimes people think that, what do I got to commission an energy management system for? And a lot of times, because I've also seen that on dashboards where people will put it in their lobby and they'll display data to the public, and it's wrong. And they're like, I don't understand why I would need to commission this. Well, I think we've kind of answered some of those questions. We have different manufacturers, different communication protocols. It gets really complicated, and unfortunately, it does require somebody to kind of verify that, like you said, the data is agreeing and that you can trust it. So great comments, guys. Definitely appreciate the participation. We're going to just drive this point home a little bit further. What you're seeing here are two images. Obviously, one's a BMS, one's an EMS. And as you kind of look at these two images, you can see some obvious differences. Clearly, the BMS picture is a lot more devices, it's more cluttered, a lot more going on there versus the EMS. And you can imagine that installing a BMS does take a lot more probably work, labor, hardware, probably more cost. You know, it really, again, starts in the design phase, kind of understanding which equipment we're putting on a building and what we need to control it. For the most part, most buildings have some level of control in them. And each usually piece of equipment or major piece of equipment has its own controller. And then we need those controllers to be able to talk to each other and or the front end, the main, you know, the main head of the system. And although there are wireless systems out there, I would say the majority are still hardwired. So there's a lot of labor involved in wiring these devices. And of course, there's equipment out there where they come kind of pre-packaged with controls. But I would say a lot of buildings have at least some level of custom programming. So that all needs to happen. And then, of course, there's like graphic screens and a lot of these little details that need to all come together for our building management system. Where in EMS, I won't say that there's never any hardware, because if you were doing a retrofit or maybe an existing building, you might need to add some sensors or some devices of things you want to measure. So it's definitely possible to need some hardware, but probably the majority of the time it could be as simple as software. I think the other thing to point out on these two images is, again, if you look at the EMS, you're seeing the data being shown in a very visual way with charts, graphs, bar charts, pie charts, data points, multiple data points on one single chart or graph. And so again, it's a lot more visual than what you typically get off a building management system. And this, again, kind of driving, again, these points home. As we mentioned, the BMS is evolving. However, I would say the original intent of a BMS is for the control of the building's mechanical systems, right? We need to be able to facilitate maintenance, you know, alarms for a critical piece of equipment that might have failed that needs attention immediately, to our basic maintenance of when do filters need to be changed, as well as being able to control comfort levels, right? Keeping people comfortable in the space. So that was kind of the primary purpose of that building management system. It should ultimately make the job of the engineers easier, and that was one of the intents as well. And then on the EMS side, it has always been and continues to be focused on energy and energy efficiency. So that's where, you know, that origin is definitely very strong in the energy usage category and optimizing it. And again, we've kind of mentioned the cost and the amount of hardware and software. So those things all can be quite different. And then I kind of wanted to finish here with an analogy. I don't know if any of you have ever heard of splitting the dictionary. So if I gave you guys kind of a challenge and I gave you the definition of the word, not the word, but the definition, and I said, use this dictionary to go find it. Let's assume it's not an easy one or one that you knew. How long would it take you to find it? I would probably say a long time. But if you're able to split the dictionary, and so what I mean by that, let's say you get a clue and I say, well, it's definitely not in the first half of the dictionary. Well, now we've eliminated 50%. And if we keep splitting that dictionary, maybe we get down to 1 or 2 pages. Now, may not give you the exact answer, but it has significantly, increased our focus on where to look. It's much more efficient, and again, kind of points us in the right direction. To me, that's what an energy management system does. It doesn't always give us the exact answer, but hopefully it's pointing us in the right direction. And then one other analogy is our bowl of fruit over there. So if we assumed an energy management system is a strawberry and the BMS is a raspberry, would you eat the salad if you only had one? The answer probably would be yes. If you had both, would it be better? For me, it would be, I would say most people. So, the point being that there's some unique functionality in each of these systems, and combining them actually is quite effective, and it allows us to see that bigger picture that we kind of talked about earlier. So yeah, at the end of the day, they're not mutually exclusive. An EMS can include a BMS. This particular example is a package unit. So it's a carrier rooftop package unit. And as we're trying to kind of understand our building and how it's performing, we recognize that we need to do a deeper dive. We've talked about being able to look at the data from end use, like the HVAC system maybe is using the most energy, or the lighting system. And then we want to investigate it further. Okay, well then what do we do? So in this particular case, data that we might typically get from the BMS and then adding our energy data again allows us to create some very specific metrics. In the case of this example, we're creating a metric called CFM per watt, which is essentially the efficiency of this piece of equipment. So once we do that, we can obviously monitor it. We can set targets around it. We know what the equipment manufacturer kind of provides of the range based on load, and we can kind of just see where we're performing and whether or not if we're running the piece of equipment as efficiently as we can, or where do we run the piece of equipment most of the time. So really, it's just giving us another tool in our tool belt, right? And by creating specific metrics like this, ultimately, it should hopefully provide us more useful information to do more and to make better decisions. And again, kind of keep drilling down onto where is the issue at, or where are the energy saving opportunities at. Okay, so I wanted to provide you guys a real world example. So this is a project that I did, commissioned. What you're looking at here is a building management system, and it is an air handling unit. There's a lot of stuff on here, I know. We're going to focus on the supply air temperature for this example, which is kind of circled in red down there. And again, in an air handling unit, they're typically one of the energy control strategies that's been around for quite some time is to reset the supply air temperature. And I would say maybe 10 years ago or so, it used to be primarily based on outside air temperature. So if it was hot outside, we would reset the supply air temperature down to 55 degrees. And if it was cooler outside, we would allow it to rise up to, like, let's say 68 degrees. And so by doing that, we should be saving some energy. So that is one strategy. Now, as we've kind of continued to look for more and more ways to save energy, come up with a different way, or what could be called a better way. And so now the strategy to usually reset the supply air temperature is called trim and response. And what it really is doing is it's looking at what is happening in the building right now. What does the building need right now? So it looks at all the zones, and it kind of pulls all the zones in the building, and it says, well, how many need cooling right now? And so if you look in that circle, you'll see that first line there, supply air RST request. There's 2 zones calling for cooling. And below it is a variable that gets added into the logic. Basically, how many requests do we want to ignore before we start to reset? And so we ignore 1. That's a variable that can be changed by the building engineer or whoever. But ultimately, once we go above 1 or have 2, we start to reset that supply air temperature from 68 degrees down to 55 degrees. And there's a lot of other variables involved in this logic, like how frequently we reset, is it every 5 minutes, every 15 minutes? So it becomes quite complicated, but at the end of the day, again, it's intended to save energy and save more energy than just going off outside air. So that's all well and good. The problem is that sometimes that doesn't actually work out. And to be honest with you, I see it all the time where 1 or 2 zones let's say a typical building has 100 zones or 50 zones. 1 or 2 zones can drive your entire air handling system. And what then that means is that it sits at 55 degrees all the time at the low end of the reset, and we're ultimately usually doing a lot of cooling. So we're not saving energy. So in this case, again, we're trying to be more sophisticated with our controls. The results didn't quite turn out that way. And why is it? You know, honestly, there's a lot of different reasons for that. It could be that it's one like IDF room or MDF room that always needs cooling and happens to be on this request list. It could be that the VAV box is just undersized, and so it's always starving and needs cooling. So there's lots of different reasons for it, but at the end of the day, like I said, it ultimately means that it's not performing as we want it to and saving energy. So again, if I was being the commissioning agent, wanted to figure out if it is working properly or not, it's quite challenging to do that, and it takes a bit of effort. Where if we had our energy management system and we were able to visualize things, might be a simpler, more efficient way of doing that. So let me show you. This is actually a different building, but it's showing the same thing here. So again, we have our heat map, our red and green. In this case, we have no yellow, but ultimately, again, red means bad. So what you're looking at here is the entire building, every zone. It happens to be a smaller building, and you're looking over probably at least 2 weeks worth of data there. And you can see one zone that is either always calling for cooling, there's some problem there. But it's easy to quickly identify it and then be able to go and investigate it. What's wrong with this, you know, VAV box or whatever it is. And that's a way to get to the information or the problem quicker. If you were going to do it in a typical way on a BMS, a lot of times you actually have to go, so each zone will have a graphic screen just like this. And there's usually a tree over to the left-hand side on your building management system, and you have to like click through it one by one and kind of find the zone that is kind of driving the system. So you can imagine that method takes a lot more time. It's something that building engineers and facility engineers do not have, right? So again, I kind of go back to the fact that one of the key things about an EMS is the way they display data, and being able to split that dictionary or to get there a lot quicker is really the intent. There's a lot of value in visualization. Okay, so let's talk a little bit about new construction. So in California, one of the code requirements is to segregate your loads at your electrical panels. So everybody needs to do that on a new construction job. What that ultimately means is they're kind of already set up perfectly to add submeters to it so that we can see our loads by end use. So that's something that we are seeing definitely in new construction projects. And I really believe in kind of this end use thing. I think it can be extremely helpful because, again, you look at that pie chart and you can see immediately where the most energy is being spent. And like I said, now with new construction, what we're able to do is if we say, okay, our space heating is using the most energy, let's go take a look at it. Let's dive in deeper. Most pieces of equipment, like those air handlers or rooftop units, come and they're able to integrate into the BMS, and they provide additional information. They will provide the energy, like their energy use for that single piece of equipment. So again, if we had, let's say, 4 air handlers and we went and we looked at the data, we found that one of the 4 air handlers was using twice as much as the other 2. Maybe there's a problem there, or maybe that's where we need to look. So now what we're seeing again in these new constructions is, I mean, essentially more data, more information, and that's typically good as long as we're able to kind of get to the answers quicker, because there is such a thing as too much data. It can kind of create noise and, you know, distract you, and sometimes ultimately we don't get to the information that we need quick enough. So there is this balance between too much data and the right data. But ultimately, yeah, most buildings will have a building management system. Not all, but most. I would say that not that many buildings actually have energy management systems, even still today. It's definitely picking up, but I would say the majority don't have those. All right. Some other things to consider in the design phase is, you know, if we are going to implement an energy management system, is, you know, you really need to think about it in those earlier phases. Some things that are truly important is kind of who is the audience, you know, who will be using that energy management system. Is it a facilities engineer or is it like an energy manager? That can make a big difference on what data you want to display or how you want to display the data. And maybe you need to satisfy both parties, and that might make it different as well. So kind of defining who's going to use it, what's the information you want, what's important to you, and obviously how the data is displayed are some of the things that often get discussed kind of in that early design phase. Of course, we also need to talk about hardware, again, sensors, hardware, IT, networks, security. There's just definitely a lot of things to think about in the earlier phases. And there's also different ways to kind of, I guess you could say, purchase an energy management system. I mean, you can just straight up buy the software and you as a client can kind of manage it and maintain it on your network. There's also ones where it's kind of an application service provider where they host it on a cloud and they take care of, the database and any software updates and things like that. And then there's what's maybe considered kind of turnkey or full service, where they kind of manage the energy management system as well as they might do some of the analysis or provide reports at the end of the month or help a client if they need help troubleshooting the data, or maybe even just customizing the energy management system, because at the end of the day, sometimes our goals and sometimes the things we want to measure, they need to change. And we need somebody to be able to change that graphic or change that screen. So there's definitely different kind of, I guess, services you can get when you're purchasing an energy management system as well. Yeah. Okay. So what do we do with retrofits? If it's not new construction, there's probably more than 3 solutions, but these probably are the most common. I typically would see them just rip it out and replace it, can try to upgrade it. And then the last one being these enabled devices, which I mentioned earlier, the Internet of Things. I have a picture of one install that we did on a small project that didn't have a BMS, and we wanted to measure only some unique specific things, and it was perfect. We were able to get the data easy up into the cloud, and so it was a very cost-effective, secure. What I mean by that is it wasn't on the client's network, and of course it's customizable. So it's a pretty cost-effective way to come into either a retrofit or a building that doesn't have a building automation system and measure just what you need. You can be very specific. You don't need to measure everything. So the good news is that we're starting to see more solutions like that, because I would say typically in energy management systems out there in the market are geared towards larger clients or campuses. There's probably a lot more tools that can be used and more effective when you have multiple buildings that you're looking at on your energy management system. But at the end of the day, we need solutions for every customer, regardless of size or budget. So I am glad to start seeing you see some of these solutions. I think there needs to be more, but ultimately, at least there's some things out there to do. All right. Okay, so as we kind of wrap up today, I just wanted to throw this out there. So if you wanted to use this QR code would take you to a blog that I wrote. I've been doing this presentation for about a year now, or this class, and one of the things I realized, as I mentioned, in my job, I'm running across this very frequently with clients and even engineers, design engineers, of kind of what is the energy management system? What is the difference between a BMS and an EMS? What are the tools and functions we need this energy management system to have to be effective? And being able to communicate that was always challenging. So ultimately, I wrote this blog. It's a couple pages. I would say it kind of summarizes this presentation. I often will have a client or an engineer read it. If it can be helpful to you in any way, I just want to kind of share that as a resource. Definitely up to you, though. So feel free. And as we kind of wrap up, I think the last thing is we have another poll here. So I would love to hear kind of some of your key takeaways regarding EMS or BMS, but honestly, it could be regarding anything that we've talked about today, or again, any additional questions you have. And maybe while you guys are doing that, I feel like I need to kind of circle back to maybe one of the questions in the very beginning of the presentation regarding lighting systems. So I'm going to go ahead and answer that. And if you guys want to go ahead and yeah, share some thoughts or questions, that'd be great. So I think somebody asked about lighting systems and building management systems and kind of integrating those two systems. It's definitely happening a lot more, because what we're seeing is a lot of control strategies where we're using occupancy sensors to control the HVAC systems. And there are a couple different ways to install or implement it. I would say the most common is to actually integrate those two systems. I started, probably the first project where that happened with me was, I'm going to say about 6 or 7 years ago, so not too long ago. And today it's still a challenge, so I'll tell you that. The way I've been dealing with it is trying to get things, again, in the design phase. First of all, just kind of defining scope of work, like who's responsible for what. Because we have two systems that, notoriously never really communicated with each other. And what we need to do to kind of like accomplish some of the energy efficiency strategies is we need to be able to take an occupancy sensor and tie it to an HVAC zone. And a lighting zone and an HVAC zone is completely different. They probably don't line up. So kind of understanding who's responsible for providing which information and getting these two systems to work together. What is the control contractor supposed to do? What is the electrical / lighting vendor supposed to do? And defining that in the early phases definitely helps. Another thing that I would say is typically when we go to install a lighting control system, the vendor will come out. Sometimes they're local, a lot of times they're not local. They will come out, they will set up the lighting system, have no communication with the controls contractor, and kind of walk away. They won't label the points. They kind of look like, in my mind, a foreign language, because you will see this kind of garbage and say, well, what is that? Is that an occupancy sensor, a daylight sensor? And you surely don't know where it's located. Is it on the first floor, second floor? What room does it go to? So there is a lot of intricacies that have to kind of go into putting those two systems together. And I probably didn't answer all of your questions, but that's just a little bit of what I'm dealing with out there. And so with that, maybe I'll turn to see what we got here for questions or comments. All right, so an EMS and a BMS are not mutually exclusive, but not every application needs both. Great comments. Okay, really powerful. They are going to quickly require a workforce training, upskilling as these become more used to meet codes and decarbonization, electrification goals, which will also include energy efficiency goals. I totally agree with that statement. They are similar, but ultimately different. There is overlap. There's potential in both systems for energy efficiency and savings. That is something to pay attention to. Great comments. All right, one last here. Individually, each system can provide a lot of benefit, but integrating these two systems can provide you with the ultimate weapon to meet energy efficiency goals requirements in the near future. Great. Honestly, guys, those are great comments, and I really do appreciate your participation here. So yeah, that's kind of the end of day one. And like I said, on day two, on Thursday, we'll get into a little bit of a deeper dive, and like I said, get into some fun case studies. So I will leave that if there's any additional questions, and see if there's anything else we have before we sign off today. And Katie, I don't know if you had anything you needed to say at the end of the presentation today as well.
I just put a link in the chat to register for day two, because we had several people registered in the past couple of days for day one, but our registration numbers don't equal on day two. So there's the link there in case you haven't registered for day two. And I think that's all I need to let people know.
Okay. All right. Well, we will hang on here in case anybody has any questions here till at least noon. And
yeah, we have a couple of minutes left, and in case anybody has any questions about today's webinar or Thursday's webinar, there's our email address, the Lighting Design Lab at seattle.gov. We are Seattle City Light employees, and our website too. the Slido is nice because you can see if people are typing. I can't see if people are typing right now. Michelle, I'd say that's probably a good point to end, so we can
Okay.
thank everybody for coming today, and we will see you Thursday.
All right. Thank you, guys.